Well, welcome everybody. Got a weird green screen thing going on. That's interesting. Okay, well, today we're going to be talking about successful failures. A little bit of contradiction in terms, but hopefully as we talk through it, it will maybe make a little more sense and maybe give us some ideas about how to fail in ways that aren't catastrophic and maybe even bring some level of success. I just realized my my family uses my remote to run the dog around. She likes chasing the laser, and evidently it has made its way. So I'm going to end up just touching. I'll have to use the old keyboard method. Okay, so that's what we're talking about today. Let me give you an idea of what's coming up here, though. On the 6th, we've got David's going to be talking to us about navigating open source licenses. That should be pretty interesting. I think it's an area that we all kind of know that there's probably more to it than what we understand. So this could be a great opportunity to invite some of your teammates, devs, and different people that might find the topic interesting. It might give you a little bit of an edge on the things we use every day and how to protect ourselves from doing something that might get us into trouble later on or something like that. Okay, so that's on the 6th. And then on the, on the 20th, Gary's going to be coming talking, and we'll have other talks in here. These are just the ones I've got pinned down. Gary's going to be coming talking to us about leading large software organizations. I think that'll be pretty interesting for a lot of us. And then on the 27th, Steve Spear is going to be talking about wiring the winning organization, making it way easier to solve hard problems faster, better, and getting rewarded for doing so. Steve has a book out with IT Revolutions, and so I think this is going to be an interesting talk. And then on the, this will be, I guess, June 3rd, Steve Pereira is going to be talking to us about mapping your path to performance with flow engineering. I know that flow was one of the big things, lean and flow was one of the things that people had mentioned they were very interested in hearing more about when we did a poll. So we've got this one coming. And on the 17th, we've got Simon Wardley talking about from here to there and back again with the aid of maps. He's going to show us how to map out things and ways to think about how to make progress and look at what has happened historically. So there should be some interesting talks coming up. Hope you can join us for those. Okay, so we're talking about successful failure. So I want to take you, does anyone recognize this building? So we're going to look at some failures and talk about failures that maybe were successful in the idea that they created good things, look at what makes something successful, what makes it not. This is from, I think, 2019. I took this picture in a hotel lobby. Does anyone recognize this? Just throw it in the chat if you do. It's an area that I think a lot of people may have seen. We usually have a lot of people from Kansas City, so this is in the Kansas City area. So this is actually the Sheraton Hotel in Kansas City, downtown near Union Station. And we were there with the kids, which that doesn't seem like it was that long ago, but she's headed to college next in the fall, so they're growing up fast. And this was a picture in the lobby there. And I did not realize this at the time, but that was actually the place where there was a very big failure. And I'm going to make this work, I'm going to actually switch over to my iPad to kind of draw an image here of what happened. So in this picture we see right here, like kind of right up behind me here, there actually were 3 walkways way up here in the sky that lets you walk back and forth. And in 1981, there was a problem with one of them, one of the hangings, a very, very significant problem. So let me see if I can get this up here so we can actually draw it out for you so you can see what happened. Let's see. So I had this all set up to where I thought I could share and draw over the PowerPoint, but then it decided it didn't want me to do that. So I'm going to just get down here and I'm going to try to draw out what actually occurred. So the way that these were, I'm going to share. Quite what I had in mind. There we go. Okay. So the way that this was laid out, oops, we're going to get all my email thing. So we had a series of, the way it was designed is there were these hangers coming down from the roof like this. Just looking at a side of it. And then there was a walkway with concrete in it that went across like this and a railing. And then another walkway down here. So this was on the another walkway there at the bottom and then a railing as well. So something like that. and the way that this was designed is it would let you get through the atrium from kind of the service area where the conference rooms were and stuff like that, all the way over to the where the hotel is. And this is the hotel that's used to have a rotating restaurant at the top. It's not, it does not have one anymore, or it's stationary now, and it's like the club lounge or something up there. Anyway, the way that these were so there was one at I think this was the second floor, and then this was the fourth floor. And then there was another hanging thing that was coming down back. There was another one that connected the third floor, but it was on a separate thing. So the way that these were designed, if you looked at them, was it did something like this. So here was our, there was a cross piece that went across like this. And then actually, I'm going to make that a little bit smaller so we get a better view of it. Okay, so we had a cross piece that went across like this on the fourth floor. And then another cross piece that went across. So this is looking straight at it, straight on. And then there was these hangers that would come down like this from the top. I'll draw it from the bottom, like this, going through that. And there was a bolt here and a bolt here. And another one that went like this. And so each of these hangers was designed, I think if I remember my numbers right, to hold about 20,000 pounds. Was how much those hangers are supposed to do. So people would be walking on it like this. That's where the people would be. And then there'd be other people up here. It's not to scale, obviously. And so what happened is these hangers were going to be threaded. And so the idea was this wasn't any big deal because you could add a bolt down here at the bottom pretty easily. And screw it on. But this bolt right here was problematic because to get that bolt in place, you'd have to screw it all the way up this entire thing. And that was expected not to work very well because the threading and stuff was seen as being problematic. And the way this worked is there was an architect that designed it, then an engineer actually engineered it, kind of showed how it would work, and then they gave it to the fabricators. And there was a process in place, which makes sense, for the fabricators to come back and tell the engineers, hey, we think this would be a little simpler way to do it in order to take advantage of what the fabricators could do inexpensively to stay on time and under budget and stuff. And so what the fabricators came back with is they said, and here, let me show this here. So this one would also support another 20,000 pounds on each of these hangers. So the fabricators came back with is they said, it's going to be really hard if we want to actually screw that bolt all the way to the top. So they proposed a different design. And that design was to look like this. So in this case, so we've still got our two walkways here. And they were going to have one hanger come down from the top right here and have a bolt on it. And another hanger come down from the top and have a bolt on it. But instead of going all the way down to the second one, they're like, okay, this will be easy. We'll just we'll put another one here. They weren't, I guess, actually drawing it. And another bolt here and go all the way down. So the idea was none of these bolts would have to be screwed more than about 2 or 3 inches onto it. You wouldn't have to take and screw a bolt all the way up to the top. Now keep in mind, this was designed to accommodate about 20,000 pounds, and this was designed to accommodate about 20,000 pounds. So my question for you is, do you see the problem here? And I was going to do it as a Slido, but just type it in the chat because I can't share the Slido until I switch back. Top one should be 40 pounds. So yes, so if it doesn't immediately kind of stand out what's wrong, let's think of another thing. So imagine an engineer designed something where there's a rope coming down. This is from I saw this illustration from somebody that let's see, he's a engineering teacher at West Point, I think. So we've got somebody here on a rope and somebody here on the rope. And so imagine that, and that's kind of what the original design was like. The rework of the design was more like if you were to do something like this, and we put one person on the rope here, and then we tie a rope around their waist and put somebody else on the rope down here. Now, imagine the stress on the person right here is going to be significantly less than the stress on the person right here. And that's actually what they ended up doing here is now all of a sudden, like somebody who mentioned in the chat, The top one should be 40,000 pounds. That's right, because initially this only needed to support 20,000 pounds, but when we added it like this, that weight is not being supported from the ceiling anymore. It's actually being supported by this cross piece. And there's lots, and the cross pieces were actually constructed like, let's see, here's a side view of the cross piece. So they were constructed like this, two C-shaped clamps, and then they were welded together here and welded together here, and then there were holes through them. So looking down on it, it looked like that. So there are two holes there and two holes there, in order to make this piece up here. So that was the design, and like you point out, there's way too much stress on that wasn't there when the engineer initially designed it. And as you can imagine, that caused some problems. So in 1981, they were having a tea dance, and there were about somewhere between, the estimates I've seen are somewhere between 100, possibly as many as 100, maybe more like 60 people on that walkway. And now, if you take engineering classes, you will probably read about this, because it's a very simple thing to explain of what went wrong. But it also had catastrophic results. So this was after it actually collapsed. NASA actually has a whole case study on this, laying out here's what happened, and here's why these types of mistakes could be easy to do, even though it's a very simple engineering thing. Like, you guys recognized it just looking at it. The West Point teacher that I heard explaining this said that when he brings this up in his engineering class, he's never had a class that wasn't able to quickly identify, oh, look, this is a problem. So the issue with this failure wasn't necessarily because people didn't know what they were doing. It's because the way the communication happened. And let me throw this up for just a second. If you're interested in this case study, I mean, feel free to reach out and I'll send it to you too. But that QR code will get you that case study, just in case this seems like something interesting. Particularly reading, I think it's particularly interesting to read about the failure, even if you're not an engineer, because I think it has a lot of there's a lot of ways that it applies to software in almost any area where we're trying to do something that's complex. So here's you can kind of see, so there's my picture that I took in 2019. You can kind of see over there is that same piece. So this was the walkway on the second floor that stayed up, and here's the crash of everything that happened when it came down. So there's another picture of it. So this was a huge tragedy in 1981. I don't know if anybody's still here from Kansas City, but 114 people actually died and about 200 people were injured in it. And what happened is the top one there on the second floor, the one that should have been designed for like 40,000 pounds and instead was designed for 20, that bolt pulled through. So it dropped about 8 inches and then the whole thing came down. And here's a picture of it after. So you can see up there in the sky, those are the hangers that went to the second floor, or to the top floor one. And they're still in place. They were strong enough to support everything. It was the way it was attached to those C clamps that had been welded together that collapsed. And here's kind of a drawing. I probably should have shown this first, of how it was laid out. And if you go to the hotel today, you'll see, I think those may be open. This one I think is actually covered up now. But it was a very big tragedy from something that was very, very simple. And what had happened is, like I mentioned, you have the chief engineer actually kind of designed, here's how this is going to work. It was laid out with the architectural drawings. It was sent to the fabricator. The fabricators actually said, oh, let's do it this way. And called and talked to, I think, the second in design for the engineer. And he said, yeah, I think that sounds good, but go ahead and send me drawings of what you're wanting to do so we can actually approve it. Those drawings never happened. And the reason is because the fabricator was working on this, and this was the Hyatt Regency at the time. It's now the Sheraton. The fabricator was actually working on another project that was much bigger, but they didn't have enough capacity to do both. So they handed the project off to another firm to handle, and somehow in kind of that translation and transition, those documents showing everything and getting permission for that change never actually made it back to the engineer. Now, the engineer did eventually sign off on it, or sign off on here's everything that was happening, but based on the idea that it was still the way it was in the drawings he had submitted and the expectation, not the way that it had actually changed to. So, question for you is, what do you think the core problem was here? Was it inept engineers? I've given you just a little bit of information, but what do you think the core issue was here? Do you think it's inept engineers, poor communication and collaboration, bad metal, or poor welds? So it looks like most of us are in that, or all of us are in the poor communication and collaboration. And that's exactly right. This was not something, matter of fact, the other thing that happened is the chief engineer actually wanted to come to Kansas City and make a visual inspection of everything. Just look at everything, see if it looked like it was doing what he expected and stuff. That was denied because they didn't want to pay the extra money to have him come do it. The other thing that kind of made it harder is when the Kansas City people came, the codes department, whatever, came in to inspect things, they saw the metal, the exposed metal, and they said, you know what, it would be better for fire safety if we actually covered that metal up. So they put gypsum board or something over it so you couldn't see it anymore. So in an effort to try to make things fire safe, they actually covered up the problem so no one was ever able to see it and say, hey, that doesn't look right. So even if it had been inspected after the fact, or after the gypsum board had put in place, they probably wouldn't have seen it because they couldn't have known what was inside the covering, which wasn't part of the original design. So very much a communication and collaboration problem, and there were lots of missteps that happened along this path where it should have gotten caught, but it didn't. And if you go down kind of in that area today, this is a memorial to the people that actually died and were injured in this in this tragedy. But the legacy of this is the skywalk collapse. The legacy of it is an increase in safety in engineering projects and better preparation for disaster response. If you're studying engineering, you will probably encounter this at one point where they're explaining, here's what went wrong, here's how we've changed things to keep that from happening again. And the history of engineering is full of these things where things that made perfect sense at the time or that had some fatal flaw in them have changed the way that we do engineering. And we all take advantage of that in the safety of going across bridges and stuff today. But in this case, no one ended up, there were criminal investigations. No one was actually charged with criminal, but the chief architect did lose his license. Years later, he got his license back, started doing engineering projects again, and spent many times going around lecturing to engineers, trying to, how did he put it? Scare the living daylights out of them about this type of problem happening again. So he dedicated his life to making sure that these types of mistakes didn't happen. So in a lot of ways, there's safety we have today that was built on this. And I believe this was the most devastating structural failure in the US up until the point that the 9/11 towers came down. So it was very, very significant. So good came out of this failure, but would you consider this to be a successful failure? So think about the idea of failures that we can actually consider to be success. What do you think? Would this be considered a successful failure, or is this just it's obviously a tragedy, but would you consider this to be a successful failure? Because what we want to talk about here is how to fail in ways that move us forward in positive ways. So would this be considered a successful failure? Get a few more votes on this. And okay, I'm surprised a lot of us say that yes, and we're enjoying the bridges that we can trust today and stuff. A lot of us are in the no camp. I kind of fall into a little bit more of the no camp, that this was a failure that should have been, it was a catastrophic failure versus something that was a bunch of small failures that we feel like move us towards success. So that's why I would probably not consider it a successful failure, because not all failures are created equal. We don't want to just try to create failures, right? Or any type of failure. Failures may not be good just of themselves, but there are types of failures that are considered good. And I would say small, frequent, low consequence failures create opportunities to avoid large catastrophic failures. In this case, there were a bunch of failures that led to something catastrophic, but they weren't low consequence failures. They were very high consequence failures. And the reason I would bring this up is we need to be very careful in software, whatever area we work in, to try to drive toward not avoiding small failures that can actually be productive, but not create catastrophic failures that are going to be, very, very bad. And the story is good from the standpoint that I think we learned a lot from it, but it still was a catastrophic thing that should not have happened. So how can we create low consequent failures more frequently? Well, here's an example. Does anyone recognize who this guy is? Thanks, Eaton. That looks interesting. I'll check. You have to fail in the right way. Does anyone recognize this? Throw it in the chat if you recognize this individual. It's not Einstein, but that's close. Okay, yes, Edison. So Edison invented the light bulb, invented all kinds of things. I think he was actually kicked out of school because they said he'd never learn anything, which I think was pretty interesting. So this is Thomas Edison. So imagine you were trying to invent a light bulb. How many failures would it have taken to make you give up? Would it have been 10 failures, 100 failures, 1,000 failures, 10,000 failures? Where's kind of your failure threshold? And I'm impressed with the people that would have tried 10,000 times. I guess it depends on your budget, maybe. Like if you're failing and not able to put food on the table, and by this time Edison had made a name for himself and was able to fund his inventions. Okay, so a lot of us, and I probably fall in this camp too, that if I try something 100 times and it fails, I'm probably going to be more likely, depending on what scale those failures are, I'm going to be a little bit more likely to give up. For Edison, though, I think they count, the number I've seen thrown around was that for the light bulb, he tried 2,774 different filaments before he finally hit on one that worked well, and the other ones didn't work or didn't work as well. But what I want to point out here, though, is that his success did not come by avoiding the failures. So he wasn't trying to work in a way to avoid the failures. He was using all these little failures to move himself forward. And I think that's a very important thing for us to think about in software is how do we fail in a way that's not catastrophic? We don't want failures that kill people or put the company out of business or something like that, but many small failures that move us forward. So thousands of little failures led to a successful design. So let's talk, I wanted to look at two development projects that I've worked around. One I worked on and one I just knew of. Project A, they built all the parts that they needed and then put them together in production. This is one I didn't work on. And this was a company, I remember talking to the person, it was proceeding, Project A was proceeding kind of in parallel to Project B. Project B was the one that I was working on. And I remember I knew some people that were on this project, and I kept asking every time I'd see them, a couple times a year, like, how's the project going? And they're like, oh, it's great. We're on time, under budget. This is going to be awesome and stuff. And I said, well, how much do you actually have in production? And they didn't have anything because that was going to come later and stuff. Anyway, it was proceeding in parallel with what we were doing. Project B that I was working on, we built production first and then deployed every change all the way through the process, all the way through. What was interesting, though, to think about is Project A had minimal failures during development. There were a few things that went wrong because they weren't trying to deploy to production. So they worked in a way that minimized the number of things that could go wrong with the idea that that would help them develop things very, very rapidly and nothing would slow them down as they're writing the code. Project B, on the other hand, that I was working with, we had all kinds of things failing during development. Here's some of the failures that we ran into. So the storage array that we were working with had performance issues, and we found some things that this, don't remember if it was $1 million device, maybe $500,000 device, that the people that created it didn't know it would do under certain circumstances. We also found the change management process didn't allow for rapid deployment, so we had to change the change management process. Security findings for production environments slowed the work. So as we were deploying stuff, we were going through the full security review for getting things through to production environments, and that was slowing things down. SSL certificates. I remember one time we came in, no one could do any work because the SSL certificates had expired and stopped working for the day. Network access in production was very problematic to set up, and because it had so many controls around it, we had to go through lots of things where we'd try to do something and then it would break or break something else, and it was just a lot of pain and suffering around that. The devs would check in a change. I remember one time devs checked in a change, it broke all the tests, and everyone had to stop working until we fixed it because no one could actually do anything. Large number of tests took a long time to run. Tests were flaky and failed because Selenium connection issue. There's lots and lots of things that actually went wrong as part of this process. Oh, I had 2 slides of this. I forgot. So deployment to production would hang sometimes, couldn't get it through. Conversion scripts wouldn't finish because we did that early on. Since we were working with production, we were doing conversions of the existing data even before we had the whole application written. And there were lots of failures associated with that. One thing because the whole application wasn't written, but because we discovered all kinds of things in the data that wasn't wasn't the way it was supposed to be, so we had to update those as we were going. The databases were too slow to meet the service level agreement. We also found out, so we used a different database for that, and then discovered that the servers that we had ordered didn't have enough RAM on them, and had to put more RAM on. And this was all before we went live. We were just lots and lots of failures as we were going live. Project A failures, on the other hand, there were no major impediments to the development effort. All those things that we listed earlier, they didn't hit any of that when they were in the development stage. It all went very, very smoothly for them until they went to deploy to production and nothing worked. And they ended up very much missing their date. I think they did eventually get live, but there were lots and lots of failures or lots of very significant failures, particularly the one that they couldn't deploy when they tried to go live. And the difference between these two projects is Project A intentionally avoided things that could fail because they didn't want it to slow them down. Project B intentionally did things that might fail early on and kind of embraced that, so it just became the way of working. So they had lots of things that went wrong kind of one at a time. And particularly going wrong one at a time, where it's like, hey, we made this change and it caused this problem, let's fix it and see what happens. Instead of getting to the very end and discover that 100 or 1,000 decisions you made kind of in the vacuum weren't going to work. And so now you've got all these things that interact in very complex ways. So bringing the failure early on meant that you could deal with things one at a time and improve from it. So those were two very, very different approaches. And what I see as one core difference between the two projects is Project A was trying to avoid things that could fail. Project B was intentionally saying, if it could fail, we want it to happen as soon in the process as possible. So if deployment to production might be hard, like there's something that could go wrong, let's discover that before we've written our entire application. Let's bring that failure so it happens while we're writing our application. Yes, I like to pull the pain of the failure forward so we experience it when there's less complexity to deal with, when there's a better knowledge, a better understanding of what the last thing was that just changed. And all those little failures early on made it to where the project, instead of getting slower and slower as time went by, it actually got faster and faster at what they were able to deliver. That was on Project B. Project A, on the other hand, since they had avoided all that failure, it compounded, and then they were dealing with the interest on the failure that they could have experienced early on. And so that project got slower and slower and slower as they got closer to when they wanted to go live, where Project B actually got faster and faster. So hey, here's two other projects. Project C started out by trying to process a file. This particular thing was going to process all these files that were coming from different sources. So their first goal was just saying, can we take a file in, do something to it that we're going to need to do for processing? I don't remember the exact steps. Was do that and see how long it takes. Just, can we process a file in some way? And ran into lots of problems with it. And the files not coming. First they had to get files that were actually valid. I mean, lots of stuff around that was very, very painful. Project D, on the other hand, started building a generic deployment pipeline. And their logic, which I feel is the logic of Project D, I felt was very similar to the logic of saying, hey, we want to change these hangers in a way that makes perfect sense, but maybe doesn't understand the full consequences of what they're doing. They started by building a generic deployment pipeline. And the reasoning was, if we get our pipeline in place, then we'll be able to deploy stuff fast and the project will be able to move very rapidly because we'll have invested everything in up front and we're not going to have to keep building the pipeline as we build the application. And that sounds like a very, very good idea. And the part of me that loves having just a system for delivering code all the way through makes this great. And by a generic deployment pipeline, the goal was that not only would this team use it, but they could prove it out and then the entire organization could use it and it would be nirvana for delivering software. So Project C, the one that started with processing the file, they built just enough pipeline to handle the current application. So that first part of processing the file, they only built the part of the pipeline they needed to deploy that all the way through. And they made it work fast because they needed to keep making changes to these files. And they do changes to the processing. And they do things like deploy some new code, run it overnight, come in and look at the numbers. And I remember we had a spreadsheet and everybody go and look at the spreadsheet. It's like horse races, right? How long did it take to process this file? Last night it took 30 minutes. Tonight it took 15 minutes. Okay, we made some improvements. Or it failed entirely or whatever. So there were all all these metrics that were being looked at. So the deployment process was automated based on just what they needed to do. They often had to redo the deployment pipeline as the application changed, because when they created the pipeline at first and deployed it, a pipeline at first to deploy just what they needed, once they added some stuff to the application, they may have discovered, I remember we discovered that some of the things that worked fine for just deploying that piece did not work once we added another part. And there were interactions with it. This thing that we did at the second stage caused the first stage to fail, so we had to rewrite it. And all the things that the other project, Project D, was trying to avoid, Project C was experiencing. All that pain they were trying to avoid, we were experiencing. So if you had gone through this process, it might have made you feel like Project D would be a much better approach to things. Also, the pipeline frequently went down as it evolved. It was a shared ownership of the pipeline, and there were often times where somebody would be typing in the chat or in the video team room and say, "Hey, pipeline's down. I'm working on it. We did this. Here's what we think we did. If you want to come join, help me troubleshoot it. Would love your help. Hopefully we'll have it up in a few hours." But you can't deploy anything until we get this fixed. So that was the continual process that we were living with this. Project D, on the other hand, the pipeline was built out for an example app before starting on any work in the domain. There were many architectural decisions that were built into the pipeline design. And the pipeline worked very well for deploying the example application. It worked fast. They had different parts of the example application that they could deploy all the way through. But then it turned out the pipeline that they built turned out to be completely unfit for deploying the application that the customer actually needed to be built. So there was, in this case, I think it was about a year working on the pipeline to deploy this example application without actually working on anything that was in the problem domain. So we had these two approaches. Problem C started with very small failures that were provable in the project domain. So Project C was trying to do stuff with the pipeline and kept running into these small failures because within the problem domain. So they were working on processing this file, which is something that was in the problem domain, and they hit lots of small failures with that because it was complex. It was a hard thing to do to grow this pipeline as they were building the application. Project D started by fixing problems that were hypothetically within the problem domain, but later turned out not to be within the problem domain. The problem domain turned out to look a lot different than this hypothetical model they were building against. So problem D, starting with the pipeline, in this particular case, 3 teams were working on different parts of the project. So we finally, and this was a team I was working with this project, and the goal was to build the entire pipeline out entirely. And through much through much coaching and suggestions on my side of things, they finally got to where they were working on the application a little bit in parallel, but the pipeline was way, way far away, way advanced of what they thought they needed to be working on. So there was one small team working on the application and 2 other teams working on tooling and building out the pipeline for this hypothetical version of what the application might look like. So the tooling team was working on a database integration tool for a few months. So it was the way that the application would talk back and forth to the database was being worked on. And they were running into a lot of problems trying to match the design, even with the hypothetical version of things. The dev team couldn't move forward because they needed that tooling. So through some miscommunication or communication and various things happened, the dev team went ahead and built what they needed just over a weekend. Just got heads down and built just the piece that they needed for this, the way it was going to interface with the database. This created all manner of conflict. The tooling team felt like the dev team had gone around them. At one point, the tooling team had actually told the dev team, well, if you think you can do better, go ahead and do it. They didn't actually mean that as the challenge it came across as, but that's how it was taken. And in this particular case, from my perspective, it was not because any of these people on the tooling team were inept in any way. They're very brilliant people. But the people I was working with on this team, by and large, were very, very good developers, very good at what they did. The tooling team, though, was trying to design a generic solution that could be used across the entire organization and prove it out with this little toy application. the idea of solving all the generic problems, because they were kind of had blinders on to what the real application needed. When the dev team took it, they were trying to solve a specific problem with the idea that it could evolve later if they ran into other problems. So meeting their immediate needs was a lot simpler to do. And they still kept it within kind of the spirit of what the tooling team was trying to do, but much more focused on, if I can get this to work, then it's done, instead of what the tooling team was doing, which was focused on kind of this generic problem that was really hard to prove if it was doing it or not. And the scope of that was much, much bigger. So there was conflict there between the teams when the dev team said, "Oh yeah, this weekend I went ahead and did this thing you've been working on for 2 months." You can kind of imagine, and in all fairness, they had solved a different problem, a much more focused problem that was focused on what the domain, the actual application needed, where that's not necessarily what the tooling team was trying to solve. But what was interesting about this conflict is the people I was working with on the team, particularly like the scrum masters, project managers, people in that, they saw this conflict and were like, "Hey, we need to cut down on the conflict," because these are people very motivated by the team being harmonious and those things. From my perspective, we had we had revealed a problem in the way that we were approaching the work. And for me, the problem wasn't so much that we're getting conflict. The problem was we're working in a way that's not actually able to deliver to the customer. And so the symptom of the problem is we've got teams that are upset at each other for stepping on each other's toes and stuff. Dev team was upset. The tooling team couldn't seem to deliver stuff. The tooling team was upset because the dev team had gone and just built it themselves, and that was getting into to their lane. But from my perspective, that was actually a symptom of what the real problem was. The real cause of the problem is we were working in a way that was not toward the same goals. The tooling team was working on trying to solve a generic problem for the entire organization, whereas the application team was trying to keep the customer happy by delivering working software. So they were just going to build what they needed and evolve it from there. So this is, I think, a key thing when we're thinking about how we approach failure, is to make sure that we don't take a failure and then look at the symptom of the underlying cause and try to make that symptom go away. When we have a failure of some type, we want to make sure that we're solving the actual problem rather than just the symptom of the problem or the way the problem manifests itself. In this case, the tension between the teams was just a symptom of the underlying cause, which was the teams were trying to do different things. This particular project ended up getting canceled because there was so much time spent on the pipeline work that they never actually were able to deliver, that they lost the customer's confidence. This particular conflict, though, was pointing to the underlying cause, or the underlying issue, which was there was different goals being worked on. One of those was not as aligned with delivering things rapidly all the way through to the customer. And the other was solving problems that were outside of the customer's domain, which ended up being kind of a cause of the project being canceled. So we look at these, some key points, some key takeaways to think about here. Design your work so potential failures happen early. Now, oftentimes we do the exact opposite of this. Oftentimes we're trying to design our work in a way that we don't experience the failures because they're painful, and that compounds the failures. I don't know if you've ever heard which I believe is a myth, but the idea that small earthquakes mean that the earth is things are shifting, tectonic plates are shifting against each other, and a bunch of small earthquakes will keep the big one from happening. Now, I think that is actually a myth, so that's not true. But that type of thinking is what you probably do want in this case. We want lots of small failures happening early on that we can fix and learn from and improve the way we're working, rather than waiting and pushing those all to the end so we discover everything at the end when it's very, very hard to figure out how to fix stuff, very expensive. Okay, key point number 2. Early small failures are better than large late failures. Kind of a restatement of what I just said. I got ahead of myself. But early small failures are better than large late failures. The sooner you can learn something about what you're doing, the longer you have to benefit from that knowledge. You want to structure your work so small failures are painful enough they can't be ignored. So in some cases, we end up designing work to where designing work in a way that makes it to where we don't see the failures because they can't happen. In other cases, we structure our work in ways that the failures are easy to ignore. Like, and let me give you an example of this. Let's say we've got our tests, and it becomes a real pain because the tests are flaky, and so we actually either turn the tests off or make it to where when they get deployed in the pipeline, failing tests don't keep you from deploying all the way through. So we're like, if it's a failing test, that's okay. We'll go ahead and we're deployed all the way through. That type of situation means that the small failures, the test failing, aren't painful anymore. There's no real drive to try to fix them because there's no pain of having them there. On the other hand, having it to where our stuff just, you can't deploy it. We've designed our stuff to where there's not a way to deploy it until you've actually got your test passing. And culturally, we're not just going to turn tests off. If they're there, if they're important enough to keep there, we're going to figure out how to make them pass. That makes it very, very painful when somebody breaks a test and no one can deploy through to production. But it's very similar to that line of like a Toyota assembly line where somebody sees a problem and they pull the lever and it stops everything until they fix that. That's a very painful process, but you want that process, those small failures, to be painful enough you can't ignore. If you're working on an area and you're waiting for the car to come through to weld it or whatever you do in the assembly line and it stops, you're going to wander over to try to see what's going on to get the line started again. You want that type of pain that I can't do my work until we actually solve this problem, not just hiding it. Don't try to fix the pain from a symptom of a failure. So coming back to the example of conflict within a team, there's times where conflict is not productive, and so I'm not trying to diminish that. But there's also times, and I think a lot of times, where the conflict within a team is just pointing to situations that need to be fixed. And just trying to get people to be happy with each other can be fixing the symptom rather than the actual pain. What should happen is if there's conflict within a team, if you can get the team realigned on here's the goal that we need to solve, you fix a lot of the interpersonal conflict. If you don't get them aligned on the goal to be solved, you just kind of hide the pain. You may make people very, very happy with each other, but if they're headed toward different goals, you haven't actually achieved anything. You haven't achieved what the project needs. Be wary of progress from outside the problem domain. There's lots of things we can do that make us feel like we're making progress. And this shows up in different ways. I mentioned the thing of trying to deploy a toy application when that wasn't what the customer actually wanted and turned out not to be where the actual application wouldn't work within the pipeline that was designed for the toy application. But it can also show up in ways where you feel like you're making progress because you're doing requirement documentations. Well, the requirement documentation, in some way, yes, it's inside the domain, but the actual thing that the customer wants is working software. And if we get very focused on the idea that we're delivering requirements without the actually delivering solutions to the problem domain, working software, we can set ourselves up for a lot of failure. Oh, and in this case, if this does happen, it can hide failures that occur once you get into the problem domain. Okay, so that covers most of, I think, are we on time? What time is it? Okay, good, we've got time. Okay, we're giving away a shirt. I think I've got these in every size. If not, I've got to turn your video on. So the winner will get a t-shirt. I just got some new shirts in and my kids will help me print them, hopefully coming up in the next week or so. So sign up to win a t-shirt. They're lovely t-shirts, very nice and soft. And we'll go through and look at a few questions from this talk. I'll give you a few more seconds to join. Yeah, and Tom, I think that's a very good point. Getting something to work helps you understand the process. If you have the idea that your programming or whatever you're building is set in stone, that's a good way to cause problems later on. If you have the idea that we're going to try this, see what fails, and then try it again, and that's one thing beautiful about code is when you're building it, the cost of failure can be very, very low if you approach it that way. If you're building a bridge and then you get to try it out, put cars on it, and it collapses. That's a lot bigger. So what they do is they build small bridges and small versions of them and stick them in air tunnels and say, how does this behave? The Tacoma Narrows Bridge, you know, the one Galloping Gertie that goes up and down. I was going to use that in here, but didn't get it put in. Was designed with a set of assumptions that basically said wind doesn't matter, or actually, it treated wind as a static force, and in that case, it didn't because it started oscillating like this. That was a very catastrophic failure, although the information they learned from it, they replaced it with a bridge that's still there to this day. First attempt in learning. Yeah, I like that. Okay, so here's our questions. Design your work so failures happen what? Rarely, early, to someone else, or obscurely. The to someone else might be appealing, but I will tell you that is not the answer I had in mind here from this talk. So rarely, early, to someone else, or obscurely. And yes, you want your failures to happen early on. You don't want it to happen obscurely so you can't see what's happening. So early. Okay, next question. It's important to differentiate between the blank of a failure and the blank of a failure. So between the person of a failure and the manager of the failure, between the failure of a failure and the specter of a failure, between the cause of the failure and the symptoms of the failure, or between the pipeline of the failure and the application of the failure. What do we want to differentiate between? Yes, we want to differentiate between the cause of the failure and the symptoms of the failure, because the symptoms often are the things that are causing pain. And if we focus on the symptoms, we may do things that alleviate the pain without fixing the underlying problem. So we want to be very careful to make sure we understand the cause of a failure and not get so focused on the symptoms that we obscure the pain from the failure. Okay, we've got Dayla is in the top spot. Congratulations, followed by Dan, Tom, and Kimberly. Next question. Be wary of making progress without getting paid that managers can't see in another dimension or outside the problem domain. So from this talk, what did we say? To be wary of making progress without getting paid that managers can't see or in another dimension. And yes, we want to be wary. And I mean, the 4% of you that said in another dimension, that probably be wary of that too. But from the talk, we want to be wary of making progress that's outside the problem domain because it may mislead us and it may also hide a lot of risks and failures that we would experience if we were actually doing whatever it was inside the problem domain. Okay, Dayla's still in her top spot by 1 second. We'll see if she can retain that, followed by Dan, Banana Man, Tom, and Linda. Next question. Structure your work so small failures are painful enough they can't be ignored, have no impact on the team, aren't noticeable to management, or never cause you to miss that should be sprint goal. Sprint goal. I think it auto-corrected or I hit the wrong letter. I just completely messed up the spelling on this one. But yes, you want them to be painful enough they can't be ignored. Structure works. So the reason I would say it's not that it has no impact on the team. If something's broken and you have a failure, you want it to have enough impact on the team that they fix it. Now, it shouldn't destroy your team, but you want your failures to actually drive change. So in this case, I'm saying you want it to be painful enough that they can't be ignored, so you can actually grow from it. Being not noticeable to management probably shouldn't be your main goal. And as far as never causing you to miss a sprint goal, I would suggest that sometimes we get so focused on trying to meet a sprint goal that we kind of avoid dealing with failures that maybe we should deal with early on. And the sprint goal, if that's driving how we manage failures and how we structure our work with small failures, we might actually be we may be pushing stuff off that will create a bigger failure later on. So that's why that probably shouldn't be the thing that's driving it. I'm not saying we should try to miss sprint goals, but I don't think that should be determining. We want to make sure that failures are giving us feedback that allow us to change the way we're working. And if the sprint goal becomes more important than doing that, we're probably just pushing things down the road in ways that could be a catastrophic failure for us later on. Okay, Dan pulls in the top spot. Within microseconds, evidently, followed by Dayla, Tom, Banana Man, and Mike G. Next question. What do you only have 10 hours to join? Okay, this is outside the scope of the talk, but you should have gotten an email about this or heard this. Should it be the Roundabout Appreciation Society? Improve your agile skills with 5 business book live class coming up. Barbershop Harmony Society or World Rock Paper Scissors Association. These are all real things. Roundabout Society Appreciation Society. Okay, so it's not that one, but it is Improve Your Agile Skills with 5 Business Books live class. So this is a class I'm offering. You should have probably gotten an email about it. Let me throw it up here real fast. We're going to go through business books. Go through 5 business books. Look at, it's a 5-week course. We take 5 business books, look at the summaries of them, go through like the 10-minute summary of it, and then really talk how that applies to what we're doing today. And the goal here is to get people very focused on how to take the information from business books and apply it to making themselves more agile. I'll throw this out here. I think we've got about 10 hours left to register for it. If you are interested, 11 hours left, I guess. We'd love to have you be part of that. We've got 10 people signed up for it already, and very good people. I think is going to drive great conversation. I'm really looking forward to this class. So if you're interested, click on that link, register. If you have any questions or if there's some barrier to it, let me know. We'll see if there's any way we can help get you to the point where you could attend if you're wanting to. But that'll be coming up and starting this Thursday. I'm very much looking forward to that. And it looks like Dayla, oh, she beat out Dan, pulled in the top spot. So very good. So Dayla, send me your shirt size. Just reply to some email I've sent you. Send me, well, here, let me type it here just in case. Every once in a while we've got somebody that got it from someone else. Here's my email. So send me an email. Let me know your shirt size and where you want it sent, and we will get a shirt headed your way. Probably one of these, depending on the size. I've got some others. I think I may be out of smalls on this. Can't remember exactly. Anyway, love to get that headed your way. Oh yes, you're coming to the course. That's great. That's great. Well, take Dayla's example, and you should come to the course too. So we've got room for some more people, and I'd love to have people. The 10 people will work out great as well, but you could be number 11, and it would be very. I think you'd get a lot out of it. It's also guaranteed. If you attend everything, you're like, this wasn't worth it, you get your money back. So it's a low risk thing. Okay, well, thank you everybody for coming. I hope that was useful. I was interested in seeing. It's always interesting to see how many people show up for different topics, and maybe learning how to successfully fail wasn't like the thing that everybody wanted to hear about. Maybe not as exciting as learning about story points and stuff. But thank you for coming. I'd love to hear any feedback that you have on this. So I'll stick around for a few minutes